Rachel here, and this is my student ID. The morphology of galaxies is various. We can divide galaxy into different morphology type according to Hubble classification. Once galaxies are classified, we can study galaxies in different categories, which will simplify the study of galaxies. Galaxies evolve with cosmic time as well. We should study galaxies at different redshifts. For comet cluster spiral galaxies are rare. They are blue, bluer than elliptical galaxies. For Hercules cluster spiral galaxies are in blue colors. The centers are orange, outskirts are blue. Elliptical galaxies in both clusters are in yellow, orange, or red colors. These colors mean there are few star formation within elliptical galaxies. The centers of spiral galaxies are orange, which means there are few star formation as well. The outskirts of spiral galaxies are blue and are forming new stars. Elliptical galaxies are in general older because the colors are redder than that of spiral galaxies. Usually when galaxy forms new stars, these stars are in different mass. Some are massive, others are less massive. Massive stars are blue and bright. Their lifetime is short. When galaxy continues forming new stars, its light is dominated by massive stars. Therefore, star-forming galaxies are blue. When galaxy stop forming new stars, its light is dominated by less massive stars. Since less massive stars are in redder colors, galaxies are red. Thus, elliptical galaxies are older. The bulges of spiral galaxies are orange. The disk of spiral galaxies are blue. This means the relative age of stars in the bulge is older compared to that in the disk. Recently formed stars are shown at the outskirts of galaxies where colors of the star-forming regions are blue. We can see active star formation in the tail of the galaxy, in the lower right corner in the image, because this region is blue and bright. Active star formation or starburst may happen when galaxies interact. For the Bell 3827, spirals 10, ellipticals 10, irregulars 0. For next cluster, spirals 6, ellipticals 13, and irregular 1. Further cluster spirals 13, elliptical 6, and irregulars 1. For the HUDF, classifying 20 galaxies, spirals 8, ellipticals 4, and irregulars 8. Starting with the similarities, these clusters all consist of spiral, elliptical, and irregular galaxies. Irregular galaxies are the bluest. Elliptical galaxies are the reddest. Spiral galaxies are in between. The differences are there are more irregular galaxies in Hubble Ultra Deep Field than that in other local galaxy clusters. Galaxies at higher redshift are more irregular. As galaxies evolve to lower redshift, their morphology becomes more regular. Our universe is expanding with time. Universe at high redshift is dense and chaotic. Galaxy interactions are more frequent. Galaxy morphology can be disturbed by interactions. Thus, we can see more irregular galaxies. At 10 billion years, there are fewer irregular galaxies in Hubble Ultra Deep Field. Because the universe keeps expanding, its density decreases. The frequency of galaxy interactions and mergers decreases. The star orbits become more regular. The morphology of galaxies is more regular. Some galaxies may run out of gas and stop forming new stars. The relaxation process may viralize the galaxies and make the galaxies become elliptical. Thus, we can see more red elliptical galaxies. So what did I learn in this experiment? I learned that galaxies can change their morphology as they evolve. Elliptical galaxies tend to be more quiescent. Spiral galaxies tend to be more star-forming. The morphology of galaxies are affected by the environment as there are more galaxy interactions in dense clusters. Galaxies evolve with the universe. which studied galaxy formation and evolution under the cosmic frame. And these are my references.